FindXYZ is back again. We are still in a series of Road to WASSCE 2026 as we get ourselves ready for this battle. Let's take a look at this question. In the diagram, O is the center of the circle and angle OXC is 19 degrees. You are tasked to find angle XYZ. Now XYZ is solving for XYZ. So let's dive in. Line OX is a radius and line OZ is also a radius. And a line drawn from the center to any point of the circumference is a radius. And since it is a radius, we can see that line OX is equal to line OZ. Why? Because radius. So this creates an isosceles triangle. So we can have triangle OXZ being an isosceles triangle. An isosceles triangle, we have two angles being equal, right? So we can say that angle OXZ is equal to angle OZX, which is equal to 19 degrees. So angle OXZ is 19 degrees. Then we can also say that the sum of interior angles of any triangle add up to 180 degrees. So if that is the case, we can say that angle OXZ plus angle OZX plus the center angle, which is angle XOZ, should add up to 180 degrees. Then we know that we have two angles that are equal. So we have 19 degrees plus another 19 degrees plus angle XOZ should give us 180 degrees. 19 degrees plus 19 degrees will give us 38 degrees plus the center angle should equal to 180. Then we take away 38 from both sides of the equation. So we have the center angle, which is XOZ, to be equal to 142 degrees. So we have 142 degrees. We have an angle at the center. However, we cannot say that this angle at this center is equal to this angle, right? But once we find the exterior angle, then we can say the exterior angle at the center is twice angle XYZ. Let's find the exterior angle. So we know angle at a point. Now angle at a point sum up to 360 degrees. So we can say 142 plus the exterior angle should be equal to 360. We take away 142 from both sides of the equation. We have the exterior angle to be equal to 360 minus 142, which will give us 218 degrees. So our exterior angle is 218 degrees. The two should sum up to 360. Now we can apply the angle at the center theorem. So angle at the center, which is 218 degrees, is twice the angle that we are looking for, which is angle XYZ. Please subscribe, okay? If you are enjoying this one, kindly subscribe. Let's carry on. So what we do is we divide both sides of the equation by 2. Then we can say angle XYZ is 218 divided by 2. That will give us 109 degrees. So we have it here, 109 degrees. That is angle XYZ. However, there's also another way we can go about this. We can also create a line from X to the circumference and create another line from Z to join the first line. Then we'll create, let's say, a point, say A. Then what do we do? A, X, Y, Z, cyclic quadrilateral. What is so special about the cyclic quadrilateral? Cyclic quadrilateral opposite angles sum up to 180 degrees, right? So now we have angle at the center theorem. We can apply that. So 142 will be twice this angle. So we can say 142 is twice angle XAZ, right? So if you divide this by 2, you divide this by 2, angle XAZ will be equal to 71 degrees. So we have 71 degrees. Then in the cyclic quadrilateral, opposite angles are supplementary. It means that they add up to 180 degrees, right? So assuming that we didn't know angle XYZ, we can say 71 degrees plus angle XYZ should be equal to 180 degrees. Then comfortably we subtract 71 from both sides of the equation. Then we have angle XYZ being equal to 180 minus 71. That will also give us 109 degrees as we showed earlier. Ladies and gentlemen, if you found this helpful, kindly share this video to all your friends, leave a comment, subscribe to the channel, and I'll be back with another solution. I'm out.